So this is my own ESP32 car, right? You can see as an overview, the cardboard box on the outside, we have an OLED screen at the front, we have our wheel system at the bottom here. If we open it up, we have a little cover so we can put some storage in here. You can put small things, a small speaker, and we're controlling this all through another ESP32 made remote. So you can see ESP32, a joystick, and we're powering this all by a power bank. So my inspiration for this project actually came because I wanted to make a DC motor microcontroller car. Something like this Arduino one, or even this one right here. But the problem was, I didn't have a proto board, I didn't have a soldering iron, I didn't even know how to solder, I don't have a motor driver, and the only thing I had really was one 360-degree servo. And so the scale of this project was really limited to how big my breadboard is, and how I could use that rotational motion of the servo and translate that into translational motion. So I'm no expert in electronics, and I'm pretty much a beginner, still learning a lot about how these things work. But what I love about this is being able to take my ideas and actually make something out of them, and that's why I like it so much. And so even though there were a lot of obstacles when I tried to make this project, I immediately thought that I needed to take inspiration and be able to do research on how I can actually make this work. And so when the idea of making a car first came into my mind, the first thing I tried to take inspiration from was the actual cars in our world. So there are a lot of different drive systems in these cars, such as front wheel drive, rear wheel drive, all wheel drive, and the one thing that caught my mind was the rear wheel drive. Now before I could implement this into my project, I was actually facing one major problem. How was I supposed to make the wheel system for the entire car to run on? Yep, that's right, I'm using Legos to build the entire wheel system of the project. Now, I very conveniently had this Lego Technic cargo airplane set from when my brother used to build it. And being the resourceful person I am, I decided to take just a few little pieces to help me build this project. So this is the final version of the wheel system. We have the steering and a revised part of the wheel and engine. You can see there's a better mount to keep everything in place, and there's also 4 wheels to provide more traction. And now when we move the joystick module, you can see we can change the speed of the wheels as well as the direction. And we can also determine where the car goes by steering. Alright, let's look at the inside. So we're going to open it up. See, storage space right here. We can take this out. There's an OLED screen displaying a little robot face. Take this out, open it up. So you see, power bank powering the whole thing. Let's unplug it. Now, ESP32, you have 2 Lego pieces holding it in place. Capacitors for your servos. And then here, the steering mechanism for the servo there. It's all wired up together. So now I'm going to showcase the code that is used for the car. Now all of this was done in the Arduino IDE, and I just simply connected to the ESP32. So first we're going to initialize the libraries. We're using the ESP32 servo one. We also are going to use the ESP now protocol, which is how we communicate from one ESP from the remote into the car. We also have these ones, SPI wire, and these Adafruit ones for the OLED screen. And then we just have these variables here, which is used for the OLED. We make the object the OLED, and also these for the logo height and width when it initializes. So moving down, you can see I have all of these over here, from 0 all the way down to 49. So this looks like a lot, and it actually isn't a lot of code. It's actually just monochrome bitmaps that are used to display on the OLED. So because it's a robot face and it's not just individual pixels, I need this to be able to display these individual faces. And so when I want to actually animate it, I have to iterate through all of these in really fast motion to make it look seamless. So to do that, I put it all into one array, so then later in the code, I can iterate through them very fast in a loop and it'll look like a GIF. Moving down, we have the number of emotes, and we have this show bitmap function, which essentially just puts that image onto the OLED. And then so we also have this one called the task OLED, which basically iterates through all of those 50 and it updates on the OLED screen very fast with a 50 millisecond delay, which makes it seem very animated. Moving down, we initialize the Wi-Fi, and the Wi-Fi channel is going to be 6. We have this variable to code here and this new data variable. And so this onReceive is our callback function for the ESP32 now. So what happens is, if the length of the data received is also the size of the code here, that means they match, and we're going to copy the data into the code. Now if it doesn't match, that means the data we received isn't valuable because it's not going to be what we want. So we just return and nothing else is going to happen. So we're going to initialize the two servos, the motor and the steer, and then in our setup, we're just going to do a lot of initializing. The serial port for some debugging, we're going to do the OLED screen, all of that for the ESP32. We're going to attach the servos onto 2627. We're going to set the steering one to a set angle so it's straight when it starts. And we're also going to run another task on a different core. So we're going to run the OLED task, which is displaying the image, on a different core. So the ESP32 has two cores, core 0 and core 1, and you can run two separate tasks so they don't interfere with each other. Now by separating it, the OLED can update on its own, and it can also receive data from the remote separately, which doesn't interfere with each other. Now in our loop, we can see if new data. So if new data is transferred from the remote to the car, then we're going to do some of the actions. So we're going to set these parameters. These are for the speeds and these are for the degrees of the steering. We're going to write it to the servos. And if else, then we're just going to write everything to 0, and we're also going to keep the steering mechanism in this initial position. Now a car without a steering wheel is like I don't even know how to explain it, man. Anyway, my car needs a remote, so we're going to take a look at how this remote works. Looking at the remote, it looks a lot simpler than the car. All it is a breadboard, you have the ESP32, the joystick module, and it's all being powered by the power bank. And so if we take a look at the code, it's a lot simpler as well. We first define the pins that we connect to. So we have the VRX, the VRY, and the SW for the joystick module. We have these for the ESP32 Now protocol, and I have the MAC address of the pure ESP32, or the one that's inside the car. So we have the ESP Now pure info here. We have the same variable to code as in the car. And then in the setup, it's a lot simpler. We just begin the serial port in case anything goes wrong, so we can do some debugging. And then we initialize the ESP Now protocol, ESP Now initialize. We do some copying, pure info, all of that. And then we say it's ready to send. And then so in our loop, all we're going to send is the X that we read from the joystick module, the Y, and occasionally the SW, where the press down button, which we don't really need, but just there for anyways. And then we send that over through ESP32 Now. So that's it for this project. If you liked it, drop a sub, and I'll see you in the next one.